Hello, guys. This is chapter 17. This is going to be a really short chapter. I picked out what I really wanted from this chapter, and I excluded a lot because it's not just covered in the AP content. So, again, this is going to be a really quick chapter. So, chapter 17 looks at what speciation specifically is, and that's the production of a new species from evolution. But we're going to kindly briefly go over what a species is beforehand, and this is a really tough concept to kind of even really talk about just because this is the gray area of science or biology. This is one of the gray areas, I should say. But basically, we don't have a good definition for a species. No definition is perfect and fits all species. Species that are extinct, like dinosaurs. It's tough to tell whether the species or the organisms we find, the fossils, were completely different, or maybe they were just like the adolescent form of an adult, or what time period, or we find a rock layer. We don't know if two species or two organisms might be able to reproduce or not. So this is it's not perfect. Species that don't reproduce sexually, we can't really give a good definition because how much difference does a bacteria need to be a new species? And another asexually reproducing species as well. The age, life cycles, and variation. We see different forms of an organism. Think about like a tadpole going into a frog. Hundreds of years ago, you might have thought those were two different completely species if you found them separately, but we know that they mature into one or into the older one. So it's just not a great definition. There's no great perfect definition. One of the definitions we use is just the biological species definition, and that's when two organisms are able to mate and produce fertile offspring. Again, this isn't perfect. We have even problems with this one, but basically, that's a pretty simple definition that we use in this class. All right, I have a really good activity for this specific concept, and we're going to do it in class, and I'm actually really excited because it's my activity, and it's just a really good activity to show the difference between micro and macroevolution. Microevolution is just small phenotypical changes, so like allele frequencies changing. The individuals don't evolve, the populations do. You can see here the microevolution is just very small changes. Macroevolution is like going from dinosaurs to birds. That is speciation. I love this image again. Microevolution, small changes. Macroevolution, large changes. So macroevolution is just a bunch of microevolutions at a larger scale. People will wrongly say, "Oh, I accept microevolution, but not macroevolution." No, like macroevolution is just a lot of microevolutions. Like you can't take one without the other. All right, isolating mechanisms. So these are pre-zygotic isolating mechanisms. So this is something that would interfere with a zygote being produced. So habitat isolation. So you can see here different habitats of the giraffe species, and they also have different patterns on their fur. And it's just due to different locations in Africa. Temporal, and this is just when the species are mating. You can see here different types of frogs, even though they're very closely related. They're going to have different times where they have like their breeding seasons, and they just don't overlap. So they're not going to have a chance to even have a producible zygote. Behavioral, so like the blue-footed booby here has a very ritual dance, or very noticeable ritual dance. It's a courtship dance, and other birds aren't going to be attracted to that dance. So it's isolating itself based on attractions. There's not even going to be a chance for a zygote to be produced if that bird's not attracted to that dance, or not taken in by that dance. Mechanism. So this one's kind of the awkward one to talk about. All I like to say is these two dogs aren't going to be able to mate unless humans intervene. So in the nature, in the wild, like it's just not going to work. The mechanisms for the zygote to be produced don't work together, if that makes sense. Gamete isolation, and for some reason, even though all these other ones don't apply here, sometimes the zygote just doesn't produce. It just doesn't. They don't fuse. I'll show you a video here on the birds of paradise. It's an awesome video. But moving forward, post-zygotic. So even though a zygote does get produced, like between, you can see a horse and a donkey, the mule here, it's not fertile, it's sterile. So you have these post-zygotic. So even though this is a new species, it's not really capable of producing fertile offspring. So yeah, it's just not going to work. I'm sorry. Speciation. So this is the process of a new species being produced. And you can see you can have these branching events, which we're going into in the next two chapters. But basically, this is when a new species is produced by evolution. There's a couple different ways that this occurs. Allopatric speciation is the most often, is like I would say it's not the used, but it occurs most often in nature, where you have a geographical separation between a species. Something happens where they just become geographically separated. One of the species is changed, or both the species are changed in a way where they're not going to, even if they come in contact with each other again, be able to interbreed and produce the viable offspring. So this is just when a geographical barrier, in comparison to when there's no geographical barrier and you just have a large enough mutation or change in a small population where it speciates within the population and it's not able to interbreed with that species or the whole overall species. I've heard some arguments, and I don't know where I fall on this, where there's really not sympatric speciation. For some reason, there is a geographical barrier always, and that like this blue population, there's just something going on where maybe there's just a little bit more distance between the other species or the other organisms. I've heard arguments both ways. More arguments, no, sympatric speciation is just plausible. It occurs less frequently than allopatric. And you can see here the difference between allopatric with geographical and sympatric within. Adaptive radiation. This is when you get a lot of new species from a single ancestor species. This is what we saw on the Galapagos Islands, and this is just due to the species inhabiting a new location. The Hawaiian honey creeper. That's another one that went through it. You can see here our ancestor founder species, and they have a lot of different types of beaks on those Hawaiian islands. Lastly, punctuated versus gradualistic model, and this is just one more way of just looking at how species evolve. And these species are going to evolve either by rapid evolution or more gradual evolution. Rapid is punctuated. Like just think about punctuating, you're kind of moving to the right very quickly. And then gradualistic is just slow change and slow changes here. You can see the gradualistic here versus the punctuated.